All right, so we are still in Chapter 2, Section 3. This is the second video. And what we're going to do is we're going to leave some of that theory behind and jump into some examples. And so notice the first example says, find the general solution to the following differential equation, right? And so here's the following differential equation, and we also have an assumption or a given that x is greater than 0. Okay, now, as you need to fast forward like you were taking the first or second or third test or final, and what is going to be your strategy, right? So you might try separation of variables first, okay? And then when you start running into trouble, you might try to figure out if it's linear. Well, remember, what would it look like if it were linear, right? So we said that linear equations, right, differential equations, can be written as dy dx again, I want to just make sure I'm using the same notation that your book is using, right? So I think we used, I'm fairly positive we used P and Q, but I just want to make sure first. Yeah. So dy dx plus P of x y is equal to g of x. All right. So let's you and I agree that the form that this differential equation is in right now does not look like the linear equation form, right? We should have dy dx by itself here. We need to get rid of this 1 over x. So okay, so we can do that if we just simply distribute, right? Okay, both sides of the equation by x. Then let's go ahead, let's do that, and let's see if that looks like a linear differential equation. So if we do, that would be dy dx, right, minus, I'm gonna minus 2y. Okay, does it make sense that this x here cancels one of these x's here? So 2y over x is equal to, and finally, x times x here would be x squared. So x squared cosine of x. Same assumption, x is greater than 0. Okay, so again, I'm just pretending like I'm a student. I'm thinking, wait a minute, that's getting closer, but it still doesn't look like the proper form. I wrote G again. I told you my training. We used Q of x, didn't we? Okay. All right. So, but look, we can rewrite. You can rewrite this, right? We can rewrite 2y over x. That can just simply be written as 2 over x times y. And if that's the case, see how this 2 over x is a function of x, which is exactly what we needed it to be. Okay? So let's just finalize this by writing it in its proper form. dy dx minus 2 over x y is equal to x squared cosine of x. All right, so now we can rest assured this is a linear differential equation. And how do we go about using that method that we talked about in the previous video? Well, the first thing, let's go ahead and let's start to grab some information. Okay, what we know at this point. So let's go ahead, and you and I agree that p of x in this case, right? Because it's p of x times y. So p of x is equal to negative 2 over x. All right. And now, remember that u of x was that integrating factor that helped us, right? Helped us solve these differential equations. So let's go ahead and let's recap that u of x is just equal to e to the power of the integral of p of x dx. Okay? All right. Now, so let's go ahead, and what we're going to do is, as soon as you have established what is p of x, let's go ahead and integrate that. Because whatever we get after the integration is what's going to go right here. Okay? So if p of x is negative 2 over x, if we integrate negative 2 over x with respect to x, well, that's a fairly easy integration. That's just, you can use u substitution there. You can, in other words, actually you don't even need u substitution, just bring the negative 2 out, and then you integrate 1 over x, which is ln x. So negative 2 ln of x. All right, now this is what is going to be substituted here. So let's call that step 1. What is p of x? And then we're gonna integrate whatever we have defined to be p of x. Step 2 is, let's go ahead and form u of x. So u of x is going to be equal to e to the power of negative 2 ln of x. All right. Now, step 3 is we are going to end up, we're going to distribute this to this equation, okay? But before we do that, let's rewrite. So recall, right? So really quickly, I have to recall some things. So let's recall that ln of x squared can be written as 2 ln of x, right? Remember that? So what we're going to do instead is we're going to bring, instead of bringing the 2 out front like this, we're going to be going the other way. We're going to be bringing the 2 inside. So this negative 2, we're going to rewrite this inside ln. Going to make things a little bit easier. So if we rewrite this, then the u of x is just simply equal to e to the power of ln x to the negative 2. All right, now why did we take time to do that? Because remember, we literally are going to take whatever we get from u of x and multiply it to this equation in order to solve it. So if we're going to start multiplying things into this differential equation, we want to have the easiest multiplication we possibly can. We don't want to complicate things. So notice that as soon as we do that, what is e to the ln? Or ln of e, right? They cancel. So we can just simply write that as x to the negative 2. That is u of x. Let's go to step 3. We're going to use the fact that u of x is equal to x to the negative 2 to distribute to our differential equation. Okay. So in other words, we're going to come up here and we are going to distribute x to the negative 2. All right, so let's do that now. See if I can copy and paste. All right, so times x to the negative 2. All right. So if we distribute that x to the negative 2, what does that look like? So that's going to be x to the power of negative 2 dy dx minus, well, I hope this makes sense. If you have negative 2 over x, that's just negative 2x to the negative 1, right? And if you have negative 2, so if you have x to the negative 1 multiplied by x to the negative 2, you just get x to the negative 3. So that's what's about to happen. So minus, we got 2x to the negative 3y. And now, once you distribute x to the negative 2 to x squared, right? If you have x to the power of 2 times x to the power of negative 2, you have literally have x to the power, sorry, if you have x to the power of 2 times x to the power of negative 2, you have x to the power of 2 minus 2, right? X to the power of 0, which is 1. So that x squared is going to cancel out, and all you'll be left with is cosine of x. Hey, are you done? Have you solved the differential equation? Well, no, because you need to get y by itself, right? We're not done. You thought we were done? Let's go to the next page so we have some more space here. All right, well, all of this multiplying by x to the power of negative 2 is absolutely meaningless unless you can rewrite the left-hand side of the equation, right? The whole point of u of x is to be able to rewrite the left-hand side of the equation. So this is just a product rule, right? Literally, this is just, so let's rewrite. What step am I on? 3. So rewrite left side. Right, and in this particular case, we're going to be able to rewrite the left side. That is just the derivative with respect to x. Well, what did you take the derivative of? Well, it's just going to be u of x times y. And so u of x times y. That is where we're going with this. So in this case, we can rewrite this as, what was u of x? That was x to the power of negative 2 and times y equals cosine of x. All right, so now, well, I mean, if you don't believe me, take the derivative of this. See if you don't get back to where we started here. Now we're finally done with this u of x integrating factor. At this stage, we integrate both sides and we solve for y. A lot of work, and I think you'll agree with me. So a lot of work so far. So integrate both sides. All right, with respect to x, So we're going to integrate here. We're going to integrate here. Well, we integrated derivative, so we're just simply left with x to the negative 2y equals, well, if we integrate cosine of x, we get sine of x. And of course, as soon as you integrate, you need to have plus c. So let me go ahead and say integrate both sides and solve for y. So we've integrated both sides. Let's go ahead and solve for y. So we're just simply going to divide by x to the negative 2, which is the same thing as multiplying by x squared. So y is equal to, all I'm going to do is just multiply by x squared. It's a lot easier than dividing by x to the negative 2. So that would get y by itself. So x squared sine of x plus c times x squared. All right. You could factor out an x squared if you really wanted to show off, but this is your general solution to that first order linear differential equation. Okay, so this will be the last problem we'll do from this section. It might look like it's more demanding, but it's not. It's not that bad at all. Let's just unpack it so that you're ready for these types of questions. I have no background in chemistry, so I'll just do my best with. I understand the mathematics, but I have no idea or no ability to explain isotopes and radioactive isotopes and et cetera, et cetera. So let me just read. So it says a rock contains 2 radioactive isotopes, and here is the label for these 2 radioactive isotopes that belong to the same radioactive series. All right. That is that Ra decays into Ra sub 1 decays into Ra sub 2, which then decays into stable atoms, right? Okay, so we better not need to know anything about chemistry because your professor understands nothing about chemistry except the basics. So let's see if we can, they better give us some more information. So we are going to assume that the rate at which Ra sub 1 decays into Ra sub 2 is as follows. So 50 e to the negative 10 t kilograms per second. All right. Because the rate of decay of Ra sub 2 is proportional to the mass of Ra sub 2 present, the rate of change is given as follows. Okay. So again, the way I'm interpreting this is you have one isotope decaying into another, which then decays into some stable atoms, right? But the rate, so we have Ra1 decays into Ra sub 2. So there's one rate going from the first set of decaying, and then there's another rate going to stable atoms. So here's the information that they give us. So let's start. So the things that we're given is dy dt, right? This is just the rate of creation minus rate of decay. Let's see if we can unpack that in just a second. All right. And let me write the other piece of information that they give us. Oh, good. Okay, good. We don't have to do a lot of interpreting. So the rate of creation, that is that is the first round of decaying, which is 50e to the negative 10t, minus the rate of decay, which is, since it's proportional to mass, it's just k times y. All right, the good news is we could have just jumped right to this differential equation and not read any of it. Agreed? So all of this is just to give you some context, but our journey really begins here. All right, so let me finish reading. So so basically we have k if k is greater than 0 is the decay constant, where k is greater than is the decay constant. Okay. We are told that if k is equal to 2, was that 2 over, am I reading that correct? Oh yeah, so if k, wait a minute, so they give us an initial mass at time 0, y of 0 is equal to 40 kilograms. We're trying to find a mass if k is equal to 2 over, I guess the time is in seconds. Okay, I think I'm starting to get it. All right, let's see if we can translate that into some information. So here's some things that we're told. We're told that obviously k is greater than 0, and we're also told that when k is equal to 2, y of 0 is equal to 40. All right, so that is all the information that I can pull out of this problem. Let's figure out how we would solve this this equation. Okay, then let's just practice solving it. So first off, is it linear? Well, if it is, we should be able to get it in standard form. So the way I'm going to do this is we are told that k is equal to 2, so I'm going to plug in 2 right now. So since k is equal to 2, I'm going to do two things at once. I'm going to plug 2 in for k, and I'm also going to bring this whole term to the left-hand side of the equation. Okay? So that's plus 2y is equal to 50e to the negative 10t. All right, so all I did was plug 2 in for k and write in standard form. All right. So now it looks like the dy dx plus p of x times y is equal to q of x. All right. Only now obviously we're dealing with y of t instead of y of x. All right. So the goal is going to be to solve this differential equation. You should always ask, what would the solution look like? Well, it should be y of t. That's the goal. All right, let's go ahead and now that we're here, let's establish what is, I'll write it as p of x. In this case, it's just p of t. And that is whatever is attached to y. So it's just equal to 2. And if you recall, if we integrate, we need to integrate 2. This time it's with respect to t. It's just equal to 2t. All right, so then u of x, or in this case u of t, is equal to e to the power of that integral. So it's just e to the power of 2t. All right, so when I go to the next page, I'm going to bring this with me. And of course what I'm going to do is I'm going to take this e to the 2t and I'm going to distribute it to that differential equation. Ready? So let's go ahead and do that now. U of t is equal to e to the power of 2t. All right, so let's go ahead and distribute e to the power of 2t. So that's going to be e to the 2t dy dt plus e to the 2t times 2y is equal to e to the 2t times 50e to the negative 10t. Okay, so there's two things that we need to do now. So first things first, let's rewrite the left-hand side of the equation as a product, okay, the derivative of a product. After we do that, we also need to clean this right side of the equation up. So let's start with the left-hand side. So we can write this as d of dt. And what did you take the derivative of to get that? What is the product? Well, it's u of x times y, right? So that's e to the 2t times y. Now let's clean up the right-hand side of the equation. Well, if you have e to the 2t here times e to the negative 10t here, that's just e to the 2t minus 10t, right? That's just e to the negative 8t. So I'm going to write 50 e to the negative 8t. All right, well, let's go ahead and all of that works so we can integrate both sides. So at this stage, let's go ahead and integrate both sides. Okay, so we integrate both sides with respect to t. So that leaves me with e to the 2ty is equal to, well, let's see here. So this is one of those scenarios. Of course, you can bring the 50 out front. You would let u equal negative 8t, so that du is equal to negative 8 dt. So you're going to have to multiply. You can, in other words, we're missing the negative 8. So we have to multiply by negative 1/8. All right. I'm doing that on this stylus so it's not cluttering the paper. So we're going to end up having to multiply negative 1/8 on the outside of that integral. And negative 50 over 8, all right, negative 1/8 of 50, negative 50 over 8 is just negative 25 over 4. Okay, so that's what I'm about to write. So at that stage, the derivative, or I'm sorry, the integral of e to the u is just e to the u, and then we have to back substitute for u. So these are baby integrals, so forgive me if I don't take up a lot of your time teaching you things that you would have learned many semesters ago. All right, so negative 25 over 4, right? So 50 over 8, yeah, so yeah. So, and then of course we've just got done integrating, so we have to have plus c. Are we done? No, we're not done, because you have to get y by itself, right? So we need to solve for y. So I'm just going to, you're just dividing by e to the 2t, or simply multiplying by e to the negative 2t. Same thing. So what is y? So solve for y. So y, and this is of course y of t, is equal to negative 25 over 4 e to the, well, okay, if you divide by e to the 2t here, it's going to be e to the negative 8t minus 2t, which is e to the negative 10t. Plus c e to the negative 2t. All right. So can we turn this into just one big constant? No, right? Because this still has variables in it. This is not just like if you had, if you had c times e to the power of 4, then yeah, we can think about that as a constant. But at this stage, we would be done with this problem if they just wanted the general solution, right? But in this particular case, they actually do, remember, you're going to use the fact. Let me go ahead and go to another page with some more room. So all the work was, most of the work is to get to this general solution. And then all we're going to do is take the fact that y of 0 is equal to 40. Okay, that's that initial point of information. So what does that mean? So when you plug 0 in for t, we know that it's equal to 40 kilograms. So let's go ahead and plug that in. So 40 is equal to negative 25 over 4 e, well, negative 10 times 0 is just 0, plus c e to the negative 2 times 0 is again just 0. Now notice that of course e to the 0 is just 1, right? Anything to the power of 0 is 1. So plus c. All right. Last thing to do, obviously, is to solve for c. So let's just bring this to the other side of the equation. So c is going to be equal to 40 plus 25 over 4. In other words, c is equal to 185 over 4. Okay. So listen, on your test, if I ask for a particular solution, please don't leave your answers like this. Like it's not right. It's not the customer's job to take this 185 over 4 and plug it back into here for C, right? It's your job to give a quality product. So make sure you plug that back in and give me the answer. Y of t is equal to 180, wait a minute. C is equal to 185. Yeah, so let me go ahead and write that. I'm sorry. So y is equal to negative 25 over 4 e to the negative 10t plus 185 over 4 e to the negative 2t. That is your solution, the particular solution to that differential equation. And again, this had something to do with mass, right? I believe from the problem. So given decay over time. So what if you were to give this function a time, it would give you back out a mass. Okay. All right. we're going to go ahead and be done with this section. Obviously, I only did 2 problems, right? I gave you a couple different looks, a word problem and a regular problem. You're going to need some practice, so please don't just, you know, please find some practice problems somewhere, jump into some homework, and that way you can get good at this stuff. Anyway, I will see you in the next section.